Our moon holds secrets that defy everything we think we know. It is not the silent, barren rock we see in our night sky, but a world of profound and puzzling mysteries. You are about to embark on a journey to explore 25 of its most compelling enigmas. We will uncover the strange truth behind its bizarre origin, its unexplained flashes of light, and the haunting possibility that it might still be geologically alive today. By the end of this, you will see our closest neighbor in space in a completely new and thrilling light. What single lunar mystery has always captured your imagination? Our very first mystery begins at the very beginning with the moon's impossible birth. The leading story for decades has been a dramatic one, a cataclysm of unimaginable scale. Picture a young Earth, its surface still cooling, colliding with a Mars-sized world scientists call Theia. The impact was so violent it should have vaporized both planets, flinging a ring of molten debris into orbit that eventually coalesced into our moon. This giant impact hypothesis is elegant and powerful, but it has a fatal flaw. When we compare the composition of moon rocks to Earth's mantle, they are nearly identical twins. This should not be possible. If the moon is mostly made from Theia, its chemical signature should be foreign, a relic of another solar system entirely. Instead, it looks like it was made from us. To make the mystery deeper, the moon is curiously poor in what scientists call volatile elements, things like water and zinc that boil away easily. It is as if the material that formed the moon was baked at tremendously high temperatures, stripping away these lighter substances. This has sent scientists back to the drawing board, re-examining older, discarded ideas. There is the fission theory, which suggests a young, rapidly spinning Earth flung off a piece of itself, a blob of magma that became the moon. This would explain the similar composition, but the physics of making Earth spin that fast are a nightmare to calculate. Then there is the capture theory, where the moon was an independent wanderer snared by Earth's gravity. This would explain the volatile element deficiency, but the odds of such a perfect, gentle capture are astronomically low. The truth is, no single theory answers all our questions. Recent, more sophisticated computer simulations have added new twists, suggesting perhaps Theia itself was chemically similar to Earth, or that the impact created a vast, donut-shaped cloud of vaporized rock called a synestia, from which both Earth and the moon reformed. Yet the mystery remains, a fundamental question mark hanging over our closest celestial companion. How did it really get there? This perfect symmetry in our sky is a statistical marvel. From our viewpoint on Earth, the moon and the sun are almost exactly the same apparent size. This is not because they are physically similar. The sun is actually about 400 times wider than the moon. The magic lies in the distances. The sun is also almost exactly 400 times farther away from us than the moon. This precise ratio is what creates the breathtaking spectacle of a total solar eclipse, where the moon just barely covers the sun's brilliant face, revealing its ethereal outer atmosphere, the corona. The geometry is even more delicate than it first appears. The moon's orbit around Earth is not a perfect circle, but an ellipse, meaning its distance from us varies. When it is at its farthest point, called apogee, it appears slightly too small to completely cover the sun, resulting in an annular or ring of fire eclipse. It is only when the moon is closer, at perigee, that we are granted the full, awe-inspiring totality. The fact that we exist at this exact moment in cosmic history to witness this perfect alignment is itself a mystery. The moon is slowly drifting away from Earth at a rate of about 1.5 inches per year. Millions of years in the past, the moon would have appeared larger, completely obscuring the corona. Millions of years in the future, it will appear too small for total eclipses to ever occur again. We are living in a uniquely privileged window of time. This celestial coincidence has profoundly shaped human history. For ancient civilizations, the sudden, inexplicable darkening of the sun was a moment of pure terror, often seen as a sign of divine anger or an omen of doom. Yet this same phenomenon also became one of our greatest scientific tools. The total solar eclipse of May 29, 1919, provided the first observational proof of Einstein's theory of general relativity. By observing how the sun's gravity bent the light from distant stars during the eclipse, scientists confirmed a theory that fundamentally reshaped our understanding of the universe. So we are left to wonder, is this perfect alignment merely a fortunate cosmic accident, a fleeting piece of good luck in a vast and indifferent universe? Or is it a subtle clue pointing toward something more, a deeper principle of order we have yet to fully comprehend? Even as we admire the moon's serene face, it occasionally betrays a startling secret. For centuries, astronomers have recorded brief, enigmatic flashes of light, sudden color changes, and patches of misty obscuration that appear and vanish without warning. These are the transient lunar phenomena, and they hint at a world that is not entirely dead. The famed astronomer Sir William Herschel, in the late 1700s, observed what he described as red glows on the dark part of the moon, which he believed could be evidence of volcanic activity. More recently, in the 1960s, a team at the Lowell Observatory documented a series of bright red spots in the crater Aristarchus, events that were simultaneously confirmed by two other independent observatories, solidifying that these were not tricks of the eye. The proposed explanations are as varied as the events themselves. One leading theory points to outgassing, where trapped radioactive gases like radon seep from the lunar interior, disturbing the surface dust and causing it to briefly scatter light in strange ways. Another possibility is the constant rain of micrometeorites, tiny space rocks whose impacts flash into vapor upon striking the moon's surface. Some scientists even suggest electrostatic phenomena, where solar wind charges the fine lunar dust, causing it to levitate and create temporary hazy clouds. Yet every theory falls short. Outgassing should leave a detectable residue or pattern that orbiters have largely failed to find. Meteorite impacts, while common, cannot easily account for the sustained glows or the specific, localized color changes. Despite our modern fleet of lunar orbiters and powerful Earth-based telescopes, these events remain frustratingly unpredictable. They flare up without pattern in different locations and are gone before we can train our best instruments on them. This enduring mystery forces a profound question. Is the moon still geologically active deep within its core, a slumbering giant that occasionally stirs? The transient lunar phenomena remind us that our seemingly familiar neighbor still holds its cards close. Its brief, silent flash is a challenge to anyone who thinks the moon has no more stories to tell. While the moon's surface appears to be a static tapestry of gray, some of its most exquisite patterns are also its most baffling. Scattered across the darkened plains are brilliant, swirling formations that look like celestial brushstrokes or vast, ghostly fingerprints. These are the lunar swirls, and their beauty is matched only by the depth of their mystery. The most famous, Riener Gamma, is a dazzling, comma-shaped curl of bright material that stands in stark contrast to the dark volcanic rock surrounding it. For a long time, astronomers thought these might be unusual volcanic deposits, but the truth is far stranger. Each of these bright swirls is intricately linked to a powerful, localized magnetic field, a miniature magnetic bubble embedded in the lunar crust. This is the heart of the puzzle. The moon, as a whole, does not have a global magnetic field like Earth's. So where do these small, intense patches of magnetism come from, and why do they create such luminous, artistic patterns? One compelling theory points to ancient comet impacts. The idea is that a comet carrying its own magnetic field locked within its icy core slammed into the moon. Upon impact, the comet vaporized, but its magnetic signature was somehow imprinted onto the molten rock, creating a permanent magnetic anomaly. This localized field could then act as a shield, deflecting the constant, abrasive stream of solar wind particles. Over billions of years, this protected surface would weather much more slowly than the surrounding soil, which is continuously darkened by solar radiation, leaving behind a bright, swirling testament to the ancient collision. Another theory suggests the magnetic fields themselves are interacting with the fine lunar dust, somehow causing the brighter material to rise to the surface in these intricate patterns. Yet the most perplexing clue is the swirl's pristine appearance. The moon is constantly bombarded by micrometeorites, which over time should have churned up the soil and darkened these bright features in a process called space weathering. But the swirls look remarkably fresh and unworn, as if they were painted yesterday. This suggests an active process, something that is either continuously replenishing their brightness or protecting them in a way we do not yet comprehend. The lunar swirls are a clear message written in light and magnetism that our understanding of the moon's environment is still incomplete. What other dynamic forces are at work, silently shaping its surface in plain sight? For centuries, the moon was considered the ultimate desert, a world baked dry by the sun and utterly devoid of water. The Apollo astronauts brought back rocks that seemed to confirm this, appearing as parched as if they had been fired in a kiln. This belief shaped our entire view of the moon as a dead, static world. But that certainty has now completely shattered, revealing one of the most profound lunar mysteries of all. The turning point came from a daring mission named L-CROSS, the Lunar Crater Observation and Sensing Satellite. Its goal was radical: to crash a spacecraft into the moon. The target was a permanently shadowed crater at the South Pole, a place where sunlight never reaches and temperatures are among the coldest in the entire solar system. The Centaur rocket stage struck first, blasting a plume of material high above the lunar surface. The following L-CROSS spacecraft flew directly through this debris cloud, analyzing its contents before it too became a part of the moon. The results sent shockwaves through the scientific community. The plume contained not just traces, but a significant amount of water ice, with estimates suggesting the impact site was about 5% water by weight. This was not a damp patch, it was an ice deposit. Further data from the Lunar Reconnaissance Orbiter, LRO, has since mapped these frozen reservoirs, confirming that the moon's poles are home to vast quantities of water ice locked away in eternal darkness. This discovery solves one mystery only to create a far deeper one. Where did this water come from? One possibility is that it was delivered by comets and water-rich asteroids, ancient travelers that bombarded the young moon, depositing their ice in these polar cold traps. Another theory points to a constant, slow manufacturing process. The solar wind, a stream of charged particles from the sun, carries hydrogen. When this hydrogen hits the lunar soil, it could chemically combine with oxygen locked in the rocks to create water molecules. Perhaps the most intriguing idea is that some water is indigenous, seeping from deep within the moon's interior, hinting at a more complex geologic history than we ever imagined. The implications of this water are staggering. It is not merely a scientific curiosity, it is the key to humanity's future in space. Water can be split into hydrogen and oxygen, the fundamental components of rocket fuel. This means the moon could become a cosmic gas station, a waypoint for missions traveling to Mars and beyond. It can provide air to breathe and water to drink for permanent lunar bases, turning a distant outpost into a sustainable home. The bone-dry moon of the Apollo era is gone, replaced by a world that holds a precious frozen resource, a relic of its violent past and a beacon for our ambitious future. The moon's seismic whispers reveal another layer of its strangeness. After the Apollo missions planted sensitive seismometers on the surface, scientists eagerly waited for natural moonquakes or the scheduled impacts of spent lunar modules. When the modules struck, the results were startling. The moon did not just shudder and settle, it reverberated. It rang like a giant cosmic bell with vibrations that lasted for tens of minutes, sometimes even over an hour. On Earth, a comparable quake would fade away in under a minute. This bizarre and sustained resonance immediately sparked a radical question: could the moon be hollow? The data seemed to suggest a world with an interior far less dense than anyone had predicted, a shell with a vast, empty space within. This single observation gave birth to the hollow moon hypothesis, a fringe but enduring idea that has captivated conspiracy theorists and science fiction writers for decades. Some took the idea to its most extreme conclusion, proposing that the moon is not a natural satellite at all, but an ancient, artificial construct, perhaps a spacecraft or an observational outpost placed in orbit by a long-vanished advanced civilization. While this is a fantastical notion, the underlying seismic data that fueled it remains a genuine scientific puzzle that required explanation. The mainstream scientific consensus is absolutely clear. The moon is not hollow. Precise measurements of its gravitational interactions with Earth confirm it has an internal structure, including a small, solid iron core. So why did it ring for so long? The answer lies in the moon's unique geology. Unlike Earth, which is constantly churned by plate tectonics and water erosion, the moon is a single, dry, and incredibly rigid block. Its outer layer, the lithosphere, is much thicker and more brittle than Earth's. There is no water or soft sediment to dampen vibrations. When an impact occurs, the seismic waves do not get absorbed. They simply bounce around inside this dry, rocky sphere for much longer, echoing through a fractured and rigid interior. Think of it as the difference between striking a solid, dry bell and hitting a damp, muddy sponge. One will ring clear and long, the other will produce a dull, short thud. The moon is that bell. Furthermore, the data pointing to a less dense interior is explained by a partially molten layer and a mantle that is heavily fractured from eons of brutal bombardment. So while the hollow moon hypothesis makes for a thrilling story, the reality is no less fascinating. The moon's long ring is not a sign of emptiness, but a testament to its profoundly dry, rigid, and battered nature, a sonic signature of a world utterly unlike our own. Beneath the moon's silent surface lie hidden forces that actively tug at our spacecraft. These are the mass concentrations, or mascons, regions of such dense and localized gravity that they warp the orbits of satellites flying overhead. A probe on a perfectly calculated path will inexplicably wobble, speed up, or dip as it passes over one of these gravitational anomalies. Their discovery was a complete accident, first hinted at by the erratic behavior of the Soviet Luna 10 orbiter, and then confirmed by meticulous tracking of the Apollo mission spacecraft. Scientists were stunned to map these invisible heavy spots and find they align perfectly with the moon's most famous and vast circular plains, the Maria, like Imbrium and Serenitatis. These are not random heavy patches, they are the ghosts of the moon's most violent history, the colossal impact basins themselves. The true mystery is not their existence but their intensity. Other worlds have impact craters, but nowhere else in our solar system are the gravitational signatures so stark and powerful. Why is the moon's response to catastrophe so uniquely heavy? The leading theory paints a dramatic picture. When an asteroid the size of a small mountain struck the moon, it did more than just carve a hole. The impact was so titanic that it cracked the lunar crust deep down into the mantle, allowing denser material from below to surge upward. Then, in the aftermath, as the basin filled with a sea of molten lava, this dense plug of mantle material remained, trapped beneath the newly solidified rock like a buried anvil. This combination of extra-dense material and the sheer mass of the flood basalt created a permanent gravitational bullseye. Yet, crucial questions remain stubbornly unanswered. What is the exact composition of these dense plugs? Are they pure mantle rock or something even more exotic? And why did the geological rebound process create such perfectly concentrated masses here and not elsewhere? The mascons are a permanent reminder that the moon's past was not just violent, but that the violence left behind a hidden, heavyweight architecture we are still learning to decipher. The moon's surface can sometimes seem to move. One of the most baffling and controversial events ever recorded is the so-called lunar wave, a phenomenon where a wave of light or a change in brightness appears to sweep across vast stretches of the lunar landscape. The most famous account comes from the renowned British astronomer William Henry Pickering in the late 19th century. He reported observing a subtle, hazy wave of dimming light slowly traveling across the crater Eratosthenes, a gradual change in reflectivity that lasted for hours. It was as if a colossal, invisible veil was being drawn across the face of the moon. This was not a brief flash, but a sustained and deliberate alteration of the surface's appearance. The very idea challenges our perception of the moon as a static world. What could possibly cause such a large-scale, slow-moving change? The explanations are as speculative as they are fascinating. One theory suggests a temporary, localized release of gas from the lunar interior. If a large pocket of trapped gas, perhaps radon or carbon dioxide, were to suddenly escape, it could create a transient, ultra-thin atmosphere over a specific region. This temporary shroud of gas and entrained dust would scatter sunlight, creating the observed wave of dimming as it expanded and then dissipated. Another idea points to electrostatic phenomena on a grand scale. The moon's surface is constantly charged by the solar wind. Could a massive electrostatic discharge, like a silent, planet-wide version of static electricity, cause a wave of dust to levitate just microns above the surface, altering its reflectivity as it travels? A third possibility links the wave to a deep moonquake. A powerful seismic shudder could, in theory, trigger a traveling wave of dust levitation, shaking the fine regolith and creating a temporary, shimmering haze that moves across the terrain. Yet all these theories face immense challenges. No modern orbiter has ever confirmed such an event with its sophisticated instruments. The lunar wave remains a ghost in the machine of astronomical records, a single, poorly understood observation from a bygone era. Was it a rare confluence of several natural events, a trick of the atmosphere, or a genuine lunar phenomenon so fleeting we have simply never been lucky enough to see it again? It stands as a testament to the fact that some lunar mysteries are so elusive, they vanish before we can even begin to understand them. Deep within the moon's vast volcanic plains lies a feature so peculiar it seems to defy time itself. Known as Ine, this geological oddity is a D-shaped depression, a sort of irregular pit filled with an astonishingly bright and jumbled landscape of blocky material. When scientists first observed Ine in detail, they were struck by its appearance of extreme youth. The surrounding terrain, the Mare Imbrium lava plains, are ancient, dating back over 3 billion years. Yet the features inside Ine, with their sharp, crisp edges and a remarkable lack of impact craters, suggest an age of perhaps only tens of millions of years. This is a staggering discrepancy. It implies that long after the moon's major volcanic fires were believed to have been extinguished, a geological event of an entirely different nature reshaped this small patch of ground. The prevailing theory to explain Ine involves a process called outgassing, or more specifically, a sublimation eruption. Picture volatile substances, perhaps carbon monoxide or sulfur dioxide, trapped in a frothy, frozen layer deep beneath the surface. A small, lingering pocket of heat, a final whisper from the moon's cooling interior, could have warmed this material, causing it to transform directly from a solid into a gas. This sudden, explosive expansion would have blown the surface layer away, collapsing the ground into the depression we see and scattering the bright, fresh material from below across the floor. But this elegant theory immediately raises a deeper mystery. Where did these volatile gases come from, and how could they have remained trapped and pressurized for billions of years, only to release in a single, recent and isolated event. The existence of suggests the moon's interior is not the simple, homogeneous place we once thought. It hints at hidden chemical diversity, pockets of exotic materials, and perhaps even a level of residual thermal activity that we are only beginning to perceive. Stands as a quiet but monumental challenge, a small scar that forces us to reconsider the very life cycle of our closest celestial neighbor. But the moon is not just a collector of impacts, it is also a source. We find its pieces right here on Earth. Scattered across our planet's deserts and ice fields are meteorites that, when analyzed, reveal a chemical fingerprint identical to the rocks brought back by the Apollo astronauts. These are lunar meteorites, chunks of the moon itself, blasted into space by asteroid impacts and eventually finding their way to our world. This creates a fascinating and deeply puzzling asymmetry. We have Martian meteorites on Earth. We have lunar meteorites on Earth. Yet the moon's surface, which has no atmosphere to burn up incoming objects, should be the ultimate museum, preserving meteorites from every corner of the inner solar system. So where are all the non-lunar meteorites on the moon? Why does it seem to have so few rocks from Mars or the asteroid belt when it should be littered with them? The answer lies in the moon's harsh and active surface environment, a place that is far from the static archive we might imagine. The process is called space weathering, and it is relentless. The moon is constantly bombarded by micrometeorites, tiny grains of dust traveling at incredible speeds. This barrage acts like a continuous, slow-moving sandblaster, churning the upper layer of soil in a process scientists call gardening. Any rock sitting on the surface, whether it is a piece of the moon or a visitor from Mars, is gradually pulverized into dust over millions of years. Furthermore, the moon has no protection from solar and cosmic radiation. These high-energy particles slowly break down the crystalline structure of rocks, darkening them and altering their chemistry, making them increasingly difficult to distinguish from the native lunar soil. There is also the possibility that incoming meteorites striking at high velocities simply bury themselves or are covered by the ejecta from later impacts. The lunar regolith is a deep and layered history book, and foreign rocks may be hidden within its pages, waiting to be unearthed. This apparent scarcity is more than just a curious observation. It is a crucial piece of a larger puzzle. By understanding the true rate at which material is exchanged between planets and how it is preserved or destroyed, we can better map the history of our entire solar system. The moon's silent, dusty surface holds a record of cosmic traffic, but it is a record that is constantly being erased and rewritten by the very forces that make the moon what it is. Even the moon's empty space holds a secret. For a world considered a perfect vacuum, it possesses an atmosphere, but one so impossibly thin it defies our very definition of the word. This is not an air we could breathe, but a ghostly shroud of individual atoms, a discovery made by India's pioneering Chandrayaan-1 mission. The probe detected an exosphere, an ultra-tenuous envelope of sodium and potassium atoms dancing just above the lunar soil. This delicate veil is in a constant state of creation and destruction, born from the very forces that bombard the moon. The solar wind, a relentless stream of charged particles from the sun, and a constant rain of micrometeorites act like a cosmic sandblaster, knocking these atoms free from the surface rocks and lofting them into a temporary, weightless existence. The true mystery, however, is not its existence but its wild and unpredictable behavior. During meteor showers, when the moon plows through a denser stream of cosmic debris, this fragile atmosphere can suddenly thicken by orders of magnitude. Intense solar storms, with their floods of energetic particles, cause it to swell and pulse with activity. Where do these sudden surges of material come from? How are atoms transported from one region of the moon to another, painting a dynamic, invisible map of its composition? And just as quickly as it appears, this tenuous cloud is lost, with atoms either falling back to the surface or being swept away entirely by the pressure of sunlight and the solar wind. This endless cycle of sputtering and stripping makes the lunar exosphere one of the most transient and enigmatic features in our solar system. By studying the flickering glow of these sodium and potassium atoms, we are not just observing the moon, we are reading a real-time report on the conditions of space itself. This ghostly breath is a direct sample of the lunar surface, a whisper telling us which elements lie where, and a sensitive gauge for the invisible forces that flow between the sun and the planets. It is a reminder that even in the void there is motion, a silent, ethereal dance that we are only just beginning to hear. This stark duality is written across the moon's very face. The side that eternally watches us is a familiar map of dark, smooth plains, the Maria that formed the man in the moon, but turn the coin over and you find an entirely different world. The far side is a battered, primordial landscape, a chaotic jumble of towering highlands and countless craters, almost completely devoid of those vast, dark seas of lava. Why are these two faces of our celestial neighbor so profoundly different? The most compelling answer points to a cataclysm of almost unimaginable violence. Billions of years ago, a colossal impact, perhaps the largest in the entire solar system, struck the moon's far side, carving out the South Pole Aitken Basin, a crater so vast it spans nearly a quarter of the lunar surface. This impact did more than just scar the moon, it fundamentally reshaped its anatomy. The force of the collision is thought to have flung enormous amounts of heavy, dense material from the moon's mantle and splattered it onto the far side crust, creating a layer that is on average many miles thicker than the crust on the near side. This extra thickness became a critical barrier. Later, when asteroids punched through the lunar surface, triggering vast upwellings of molten rock from the interior, the thin near-side crust easily cracked, allowing the lava to flood the giant basins and create the dark Maria. On the far side, however, that thickened crust acted like a geological fortress. The molten rock simply could not break through, leaving the ancient cratered highlands untouched and exposed for eternity. Yet this elegant theory contains a deep and lingering mystery. Why was the impact and its aftermath so perfectly lopsided? Why did the debris pile up so decisively on one hemisphere and not the other? Recent computer models suggest Earth itself may have played a hidden role. In the moon's earliest days, it was much closer to our planet, and Earth would have loomed enormous in its sky. The intense heat radiating from the young, molten Earth could have created a temperature gradient, keeping the near side warmer and more pliable for a longer period while the far side cooled and solidified first. This would have made the far side crust naturally thicker and more resilient even before the giant impact, predisposing it to become the battered highland we see today. But the puzzle is far from solved. We are left to wonder if a single, definitive event set this duality in motion, or if it was the result of a complex, slow dance of heat, gravity, and catastrophic violence, a fundamental asymmetry that we are only now beginning to decode. This slow, relentless contraction is actively reshaping the moon before our eyes. High-resolution imagery from NAS, a lunar reconnaissance orbiter, has revealed a network of fresh, blade-like cliffs crisscrossing the lunar surface. These are lobate scarps, thrust faults created as the moon's interior cools and contracts, causing the crust to fracture and break, forcing one section of ground to push up and over another. Think of a grape slowly withering into a raisin, its skin wrinkling as it loses moisture. The moon is doing the very same thing on a planetary scale, its brittle crust crumpling as the world within grows smaller. These scarps are geologically young, some estimated to be less than 50 million years old, a blink of an eye in the moon's 4.5 billion year history. This discovery shatters the long-held belief that the moon is a completely geologically dead world. It is, in fact, still tectonically active. The presence of these scarps solves one mystery only to create a far deeper one. How can a body as small and supposedly cold as the moon still be generating the energy to shrink and cause moonquakes today? The moon should have lost its internal heat eons ago. The answer must lie deep within its core. Scientists now posit that the moon may still possess a partially molten layer, a sliver of liquid rock insulated by the overlying mantle. As this last reservoir of primordial heat slowly dissipates, the entire structure contracts, and the rigid outer shell has no choice but to adjust, breaking along these massive faults. This ongoing activity has profound implications. These thrust faults are generating shallow moonquakes, some registering up to 5 on the Richter scale, tremors strong enough to pose a genuine hazard to any future lunar bases. The ground we once thought was stable and silent is in reality a dynamic and occasionally shifting landscape. The shrinking moon forces us to rewrite its thermal history, revealing a world that is not a cold, dead relic, but a planet with a still beating, albeit faint, heart. What other hidden forces are stirring deep within its core, and what does this mean for our permanent presence on its surface? The very ground of the moon itself holds a bizarre and troublesome secret. When the Apollo astronauts first stepped onto the lunar surface, they encountered a substance unlike any soil on Earth. This is the lunar regolith, a layer of fine, gray dust that blankets the moon, and its properties are as strange as they are dangerous. Formed over billions of years by a constant hail of micrometeorites pulverizing the bedrock, this dust is not smoothed by wind or water. Instead, it is a landscape of countless tiny, sharp glass shards, each edge razor-sharp and unforgiving. The astronauts found it incredibly clingy, coating their suits, their tools, and even finding its way into the lunar module, where it smelled, some said, like spent gunpowder. But the most unsettling behavior of this dust occurs at the border between lunar day and night, a region known as the terminator. Here, in the shifting light, the regolith can seemingly defy gravity. It levitates. Swarms of dust particles can be seen floating just above the surface, a silent, shimmering haze that hangs in the void. This ghostly dance is driven by electrostatics. The moon's surface is constantly bombarded by the solar wind and ultraviolet radiation from the sun, which knocks electrons loose and gives the soil a powerful positive charge on the day side. On the frigid night side, the lack of this bombardment leaves it with a different electrical potential. At the terminator, this dramatic difference creates intense electric fields, strong enough to lift the fine, charged dust particles right off the ground. The exact mechanisms of this charging and levitation, however, remain a deep puzzle. How high can these dust clouds actually rise? What dictates their movement and density? These are not just academic questions, they are critical engineering challenges. This electrostatically charged dust is a nightmare for machinery. It would clog filters, abrade moving parts, short out electrical systems, and potentially pose a health risk to astronauts if inhaled. For any long-term habitat or rover designed to operate near the terminator, this phenomenon represents a formidable and poorly understood obstacle. The moon's dust, it turns out, is not just dirt. It is an active, dynamic, and almost sentient-seeming force, a constant reminder that even the ground beneath our feet on this new world is alien and filled with mystery. These ghostly impressions are the sunken memories of a much older moon. Scattered across the dark, smooth plains of the Maria are faint, circular outlines, the spectral remains of craters that were all but erased. These are the ghost craters, and they tell a story of planetary violence and rebirth. Imagine a landscape first pockmarked by the early solar system's brutal bombardment, a surface littered with countless craters. Then a new cataclysm unfolds, not from above but from below. Molten rock, lava, wells up from deep within the moon, flooding the vast impact basins. This lava does not simply cover the old terrain, it submerges it. The smaller craters are completely buried and erased from view, but the largest, most resilient craters, those with towering rims, are too big to be entirely consumed. The lava pours in, filling their bowls, but the highest points of their circular walls remain just barely above the rising tide of rock. What we see today are these drowned mountain ranges, their peaks now forming delicate, broken rings etched into the dark plain. Sometimes the ghost is even more subtle, a mere whisper of a difference in the soil's reflectivity, a faint circular stain visible only from orbit. The true power of these apparitions, however, lies not in their haunting beauty but in the timeline they reveal. Each ghost crater is a fossil, a clock that stopped the moment it was buried. By counting the number of smaller, newer craters that pockmark the smooth lava inside a ghost crater, scientists can estimate its age. The logic is simple: a surface with more craters has been exposed to space for a longer time. This dating technique has yielded a startling revelation. The great lava flows that created the Maria were not a single, brief event. They occurred in multiple, distinct episodes spanning more than 1 billion years. Some plains are truly ancient, while others are surprisingly young, at least in geological terms. This forces us to confront a deep mystery. What kept the moon's interior hot enough to produce these massive, recurring volcanic outpourings for so long? The moon is a small world, and it should have cooled down and solidified relatively quickly. The presence of these ghost craters, each one a marker in a vast geological timeline, points to a lunar interior that was far more complex and thermally active than our simple models predicted. Were there pockets of radioactive elements providing extra heat? Was the melting process more efficient than we thought? The ghost craters offer the questions, but the answers about the moon's fiery, prolonged adolescence remain frustratingly out of reach. Even the moon's apparent emptiness can deceive us. While it lacks a true atmosphere, it briefly grows a temporary, mysterious shield, a phenomenon that has left scientists utterly baffled. This is the enigma of the lunar ionosphere. For a few days each month, as the moon completes its orbit, it passes directly through the long, trailing shadow of Earth's magnetic field, a region known as the magnetotail. During this passage, something impossible happens. Sensitive instruments have detected a distinct layer of charged particles, an ionosphere clinging to the lunar surface. This should not exist. An ionosphere typically forms when solar radiation strips electrons from a planet's substantial atmosphere, creating a shell of ions. But the moon has virtually no atmosphere and no global magnetic field to contain such charged particles. So where is this fleeting ionosphere coming from, and how does it hold itself together? One theory points to the lunar surface itself. As the moon moves into the protective bubble of Earth's magnetotail, the constant sandblasting from the solar wind abruptly stops. This sudden calm might allow volatile gases trapped deep within the rocks, like radon or argon, to seep out into the vacuum. Sunlight would then ionize these tenuous gases, creating a short-lived, localized layer of charged particles. Another idea suggests that solar wind particles, which are normally deflected by Earth's magnetotail, become temporarily trapped in magnetic anomalies embedded in the moon's crust, those same miniature magnetic fields that create the bright swirls. These trapped particles could then form their own transient, patchy ionosphere. Yet neither explanation fully satisfies the data. The detected ionosphere appears too robust and too widespread to be easily explained by these localized, temporary processes. The observations suggest a more complex and dynamic interaction is at play, one where the moon's surface, Earth's magnetic field, and the sun's radiation engage in a brief, intricate dance we are only beginning to witness. This monthly apparition of a ghostly atmosphere stands as a direct challenge to our understanding of airless bodies, proving that even in the void, the moon can still conjure a cloak from nothing. This perfect, one-sided relationship we have with the moon is not a cosmic accident, but the result of a slow, inevitable gravitational dance. Our moon is tidally locked to Earth, meaning it takes precisely the same amount of time to rotate once on its axis as it does to complete one full orbit around our planet. This is why we only ever see one face, the familiar near side. The physics behind this are a story of persistent, gentle force. Earth's gravity is slightly stronger on the side of the moon facing us and slightly weaker on the far side. This difference created a subtle, stretching effect, a tidal bulge, in the moon's originally more malleable form. Over billions of years, the gravitational pull on this bulge acted like a brake, relentlessly slowing the moon's rotation until its spin perfectly matched its orbit. The true mystery, however, lies not in the locking but in its flawless precision. This synchronization is so exact that we do not see a full 50% of the lunar surface. Due to a slight wobble in the moon's orbit called libration, we actually get to peak at a tiny bit more, about 59% over time. But the core 41%, the true far side, remains eternally hidden from our direct view from Earth. This raises a profound question. Is such a perfect lock a common fate for all moons? The answer is a surprising yes. Most of the major moons in our solar system, from the 4 large Galilean moons of Jupiter to Saturn's Titan, are tidally locked to their parent planets. It seems to be the natural, final state for a moon after sufficient time has passed. So the mystery shifts. Perhaps the uniqueness of our situation is not the lock itself, but the fact that we are on the planet looking out at our locked companion. We are the ones who experience this cosmic coincidence, this perfect alignment that allows one hemisphere to be a familiar neighbor while the other remains a secret, shadowed realm. This precise balance makes our celestial partnership feel almost designed, a harmonious gravitational bond that has shaped human mythology, navigation, and our very sense of place in the cosmos for thousands of years. This ethereal glow on the moon's horizon is more than just a trick of the light. Before the sun even crests the lunar terrain, both the unmanned surveyor landers and the Apollo astronauts witnessed a strange phenomenon, a faint, luminous band hovering above the darkness. They called it the horizon glow, and we now know it was sunlight scattering off a permanent, invisible fountain of dust. These are not gentle clouds, but a storm of razor-sharp particles, electrostatically levitated and reaching surprising altitudes. The mechanism behind this ghostly fountain is a complex and still unsolved puzzle. One theory centers on photoelectron emissions. When the first rays of sunlight hit the lunar surface, they act like a burst of energy, knocking electrons out of the dust grains and giving them a strong positive charge. Since like charges repel, these positively charged particles then violently push away from each other and from the similarly charged ground, launching themselves into the void. Another idea involves the constant flow of plasma from the solar wind. This stream of charged particles could strike the surface and create a different kind of charge imbalance, while a third process, secondary electron emission, suggests that high-energy particles hitting the dust can cause it to spit out its own electrons, again leaving it positively charged and ready to lift off. The true mystery is that all of these processes are likely happening at once, interacting in ways we do not fully understand. How do they combine to create the specific patterns and heights of the dust fountains we observe? Why does the dust behave differently in various regions? This is far more than a scientific curiosity. It is a formidable engineering challenge. This charged, abrasive dust would cling to every surface, scouring solar panels, clogging delicate machinery, and infiltrating airlocks to pose a serious risk to human lungs. For any long-term habitat, especially one operating near the dramatic day-night boundary, this silent, rising dust represents one of the most persistent and puzzling obstacles to making the moon our home. There are places on the moon where the sun has never risen. At the lunar poles, deep within colossal craters like Shackleton, the rims are so high they block all sunlight, creating pockets of eternal night known as the permanently shadowed regions. These are not merely dark, they are the coldest known locales in our entire solar system, with temperatures plummeting to a staggering 400 degrees below 0 Fahrenheit, colder even than the surface of Pluto. Within this absolute billion-year-old deep freeze, something remarkable is trapped: water ice. This is not a simple sheet of frost, but a complex, layered record of cosmic history. The ice exists here because these craters act as perfect cold traps. Any water molecule that wanders in, whether from a comet impact or delivered by the solar wind, freezes instantly upon contact with the surface, and in the absence of any heat or atmosphere, simply cannot escape. It remains locked in place, potentially for eons. The confirmed presence of this ice solves the mystery of where the moon's water is stored, but it immediately creates a far more intricate puzzle. Scientists are now grappling with fundamental questions about its nature. How pure is this ice? Is it a relatively clean, clear sheet, or is it heavily mixed with the lunar soil, a dirty ice that would be difficult to process? How much is actually there, and how is it distributed? Is it buried in deep layers, or does it exist as a fragile frost just beneath the surface? The answers are critical, because this ice is the key to humanity's future beyond Earth. Water can be split into hydrogen for rocket fuel and oxygen for breathing, turning the moon into a celestial waypoint. But the survival of this ice itself is a profound mystery. How does it persist in a vacuum under a constant, though faint, rain of micrometeorites and cosmic radiation that should, over millions of years, slowly break it down? Some theories suggest it is protected by a thin, stable layer of soil, while others propose a constant replenishment from hidden sources within the moon itself. The true nature of these frozen reservoirs remains one of the moon's most compelling secrets, a treasure of unimaginable value hiding in the deepest, darkest shadows, waiting for us to finally bring it into the light. The moon's crust is etched with a secret blueprint, a global network of linear cracks and grooves that form a rough, planet-spanning grid. This is not a random collection of faults, but a systematic pattern, as if some immense force methodically scored the lunar surface with a set of cosmic straightedges. The most likely architect of this grid is the persistent, stretching pull of Earth's gravity. In its youth, the moon was much closer to our planet, and Earth's tidal forces were far more powerful. This constant gravitational kneading did not just lock the moon's rotation. It stressed the entire globe, creating lines of weakness in the crust that would later become these profound fractures. Compounding this stress was the moon's own dramatic cooling and contraction. As its hot interior shrank, the rigid outer shell had to adjust, cracking under the strain. The combination of these two forces, the external pull from Earth and the internal shrinkage of the moon itself, created a perfect storm of stress that fractured the crust along a predictable global pattern. Yet the full story of the lunar grid remains frustratingly incomplete. Why did these stresses resolve into such a distinct geometric arrangement rather than a chaotic web of cracks? The precise orientation of the grid lines seems to record the exact direction of the tidal and contractional forces billions of years ago, a fossilized snapshot of the moon's most dynamic and stressful era. But the exact mechanics of how these intersecting lines propagated across the entire globe are still a matter of intense debate. Are we looking at the surface expression of deep, mantle-penetrating faults, or just a superficial scarring of the crust? This global grid is more than just a geological curiosity. It is a direct record of the moon's turbulent adolescence, a permanent scar from a time when its very structure was being forged under immense pressure. It stands as a stark reminder that the forces which shape a world are not always dramatic impacts, but can also be the slow, inexorable, and patient stresses that leave their mark for eternity. Even the moon's dark side is not truly dark. Across its vast, sunless plains, tiny, silent explosions flash into existence and vanish just as quickly. These are lunar meteoroid impact flashes, the final moments of space rocks, some no larger than a pebble, colliding with the lunar surface at tens of thousands of miles per hour. The energy released in that instant of destruction is so immense it briefly creates a pinpoint of visible light, a flash that can be spotted from Earth with specialized telescopes. NASA and other space agencies operate dedicated programs to monitor these fleeting events, creating a constant vigil on the lunar night. This is more than just celestial observation, it is a vital early warning system. By counting these flashes and measuring their brightness, scientists can map the population of small meteoroids that swarm through near-Earth space. These are the same objects that streak through our own sky as shooting stars, but here, without an atmosphere to burn them up, they strike the ground with their full, devastating force. The mystery emerges from the data itself. The frequency and power of these impacts do not always match our predictions. Sometimes the moon is pummeled by more frequent or more energetic strikes than our models of the meteoroid stream would suggest. Each flash is a complex signature, a brief fireball that holds clues about both the impactor and the lunar ground it vaporized. The color and duration of the flash can, in theory, reveal the composition of the meteoroid. Was it a dense chunk of iron or a more fragile, icy body from a comet's tail? Simultaneously, the nature of the flash illuminates the properties of the lunar soil at that exact spot, its density and mineral content. This turns every tiny flash into a double puzzle, a brief explosion of data that we are still learning to decode. The ongoing research into these impact flashes is a stark reminder that our cosmic neighborhood is a dynamic shooting gallery, and the moon, silent and airless, serves as our perfect pockmarked witness. This subtle wobble in the moon's motion offers us a forbidden glimpse of its hidden face. Although our companion is tidally locked, it does not hold perfectly still. It rocks and nods in a delicate gravitational dance known as libration. This slight swaying allows us to peek around the edges over time, revealing not a strict 50% of the lunar surface, but a total of 59%. This extra view is the sum of three distinct and elegant motions. The first is libration in longitude, a rocking from east to west. This happens because the moon's orbit is not a perfect circle, but a slight ellipse. As it travels, its speed changes, speeding up when closer to Earth and slowing down when farther away. However, its rotation on its axis remains constant and steady. This mismatch means that for a few days, the moon's rotation lags a little behind its orbital position, letting us see a bit around its eastern limb. Then, as it swings around, it gets a little ahead, offering a view around the western edge. The second motion is libration in latitude, a nodding up and down. The moon's axis is tilted slightly relative to its orbit around Earth, just as Earth is tilted on its axis. This means that over the course of a month, we can alternately peer a little over its north pole and then a little under its south pole, as if it were bowing to us. The third and most personal is diurnal libration. This one is not about the moon's motion at all, but our own. As Earth rotates each day, an observer on its surface is carried along, moving thousands of miles from one side of the planet to the other. This shift in our vantage point from sunrise to sunset allows us to see just a little bit more around the moon's edge, a tiny parallax effect created by our own spinning world. For ancient astronomers, this slow, rhythmic wobble was a profound mystery. The moon seemed to be a perfect, unchanging celestial sphere, yet here it was, subtly swaying over time. Was it an optical illusion or a clue to a deeper cosmic truth? Today, we understand the mechanics perfectly, but the wobble remains a crucial scientific tool. By measuring the libration with extreme precision, scientists can detect infinitesimal shifts that reveal the moon's internal structure, the sloshing of its liquid core, and the subtle, relentless gravitational tugs from the sun and even the other planets. So every time you look up and see a familiar crater positioned just a little differently, you are witnessing a dance of forces that connects the moon to the entire solar system. The rocks brought back by the Apollo astronauts hold a hidden memory, a magnetic signature locked within their crystalline structure. They reveal a time billions of years ago when the moon was wrapped in its own powerful global magnetic field, a protective shield much like Earth. This is the mystery of the lost lunar dynamo. A dynamo is the engine that generates a planet's magnetic field, and it requires a churning, molten metallic core, acting like a colossal electrical generator. The evidence is clear that the moon had one, and it was surprisingly strong, perhaps even half as powerful as Earth's is today. The great puzzle is not just that it existed, but why it was so potent and what catastrophic event caused it to simply stop. The leading theory points to a phenomenon known as precession. Imagine the moon's liquid core sloshing inside its solid mantle like water in a spinning bowl. If you gently wobble that bowl, the water inside will churn violently. Scientists believe the young moon experienced a similar wobble in its axis, driven by the gravitational tug of the Earth. This precessional motion would have stirred the moon's molten iron core with tremendous force, powering a magnetic dynamo of surprising strength. But then the stirring ceased. As the moon slowly moved farther from Earth, our planet's gravitational influence weakened and the precessional wobble calmed. Without this external driver to agitate it, the core's dynamo faltered and eventually died, leaving the moon with only the ghostly remnants of crustal magnetism we detect today. This shutdown is a profound clue to the moon's entire thermal history. A magnetic field requires a hot, liquid interior. The death of the dynamo tells us the moon's heart cooled and solidified far more rapidly than our own planet's. Why did a world that once had such a vibrant, active core become the geologically quiet place we see now? The answer is locked away in those ancient rocks, a final, vital piece of the puzzle explaining our moon's long, slow journey into silence. Scattered throughout the moon's gray soil is a hidden treasure of microscopic beauty. These are the lunar glass spherules, tiny, multicolored beads that gleam with shades of deep blue, vibrant orange, and emerald green when viewed under a microscope. They were created in moments of sheer violence when meteorite impact struck the lunar surface with such force that they instantly melted the bedrock. This molten rock was then flung high above the moon, and in the perfect vacuum of space, surface tension pulled the liquid into perfect spheres before they cooled and hardened, raining back down as a glittering global shower. We understand this dramatic birth, but the true mystery lies in their breathtaking diversity. Each tiny spherule is a unique chemical capsule, a random sample of a specific type of rock from a specific depth, excavated by a random impact at a random time. One bead might be made of ancient volcanic basalt from a deep lava flow, while its neighbor could be composed of highland crustal material or even contain exotic elements from the impacting meteorite itself. This turns the entire lunar surface into a chaotic, shuffled library. Analyzing these spherules is like having millions of pages from a history book, but with no page numbers and no certainty about which chapter they came from. The central challenge for scientists is to piece together this disordered collection into a coherent timeline of lunar bombardment. How do you determine if a particular type of glass bead represents the heavy bombardment era 4 billion years ago or a more recent, isolated impact event? The chemical clues are there, but assembling them into a single, definitive story of how the moon was built and broken over eons is a monumental task. These tiny, beautiful orbs hold the entire history of the moon's violent past, but they guard their secrets closely, offering glimpses of the truth without ever revealing the full chronological picture. Our final lunar mystery arrives not from ancient rocks, but from a modern spacecraft on a deliberate suicide mission. The Lunar Atmosphere and Dust Environment Explorer, LADEE, was a sophisticated orbiter designed to study the moon's ghostly exosphere and the puzzling behavior of its levitating dust. For months, it meticulously mapped its tenuous targets, but just before its planned crash into the surface, its instruments recorded something completely unexpected. Dozens of tiny, high-velocity impacts suddenly peppered the spacecraft as if it were flying through an invisible, microscopic hailstorm. While some of these strikes coincided with known meteor showers, many others did not. They were sporadic, unpredictable, and pointed to a hidden population of dust particles, tiny interlopers traveling at incredible speeds from an unknown source. One compelling theory suggests these could be particles of interstellar dust, tiny messengers from between the stars, swept up as our solar system moves through the galaxy. Another idea posits they are fine debris from long-vanished comets, the dusty trails of icy wanderers that crossed the moon's path eons ago. Yet neither explanation is entirely satisfactory. The sheer number and distribution of these impacts suggest our immediate cosmic neighborhood is far dustier and more dynamic than our models predicted. What is the true origin of this mysterious high-speed dust? Is it a permanent, faint drizzle of material from the outer solar system, or evidence of recent, unseen collisions in the asteroid belt? The latter anomalies remain an open case, a final reminder that even with our most advanced technology hovering just overhead, the moon continues to guard its most elusive secrets. 25 enigmas, from its impossible birth to its ghostly, levitating dust, paint a portrait of a world that is anything but silent. We have journeyed from the violent paradox of its creation to the hidden water ice at its poles, from the deep, resonant ring of its interior to the fleeting, unexplained flashes on its surface. Each mystery, whether a colossal gravitational anomaly or a tiny, colorful glass bead, is a thread in a tapestry we are still learning to read. This is not a dead rock, but a dynamic archive holding 4.5 billion years of solar system history. The driving force behind every lunar mission, from the first Apollo landings to the ambitious Artemis program, is the relentless human need to answer these questions. We are returning to the moon not just to visit but to stay, to drill into the permanently shadowed craters, to deploy networks of seismometers on the scarps, and to finally understand the true nature of our celestial partner. The moon's enduring allure lies in this perfect balance of familiarity and profound mystery, a constant presence in our sky that whispers of secrets just beyond our grasp. It reminds us that the greatest adventures often lie closest to home. Which of these 25 lunar mysteries captured your imagination the most? Let us know in the comments below, and subscribe to continue these journeys into the unknown.